Now set everything equal to 0, because you notice that we have a quadratic. This is just like some of the questions that we've done before. It's going to turn out to work very nicely. I'm going to move everything to the right-hand side this time, so 0 will be over here. I have x squared. I had to add an x then, so that'll be minus 7x. And then we're going to subtract 6 to get me plus 10. So now again, I'm looking for numbers that multiply to give me 10 that have a sum of negative 7. That's going to be a negative 5 and a negative 2. That means that my two solutions are x equals 2 and x equals 5. Alright, so we have our two solutions here. I'm going to check it number 1 against my restriction. Does it pass that? Yes. Now just because it passes that, it doesn't mean we're off to the races yet. So in my check, I'll kind of write this down here. First thing I want to check is, does it pass? The restrictions, and it did. So we've done that one. Number 2 is now check original equation. Alright, so what I'm going to do is I'm going to take those two answers, 2 and 5, and substitute them in. So the equation I had was the square root of 6 minus x, so I'm going to write minus 2, plus 4 was equal to x, I believe. Yes. Okay, and I'll just do the other one over here while we are doing that. This one was 6 minus, of course, 5 plus 4 is equal to 5. Alright, so we have 6 minus 4 is the square root of 4. Square root of 4 is 2. 2 plus 4 equals 2. 6 equals 2. That clearly is not the case. Alright, so what we say now is we will say that x equals 2 is not a solution. So that one gets rejected. Alright, that one does not work. Even though it gave you an answer up there, that just doesn't work. Alright, and I'll explain to you in a second what that's exactly called. Let's try this next one over here. We have the square root of 6 minus 5, that gives you a square root of 1. 1 plus 4 equals 5. That one is good. 5 equals 5. So that means x equals 5 is a good solution. Right? Alright, to conclude this lesson, what we can say is that all solutions of equations should be verified by substitution. That's what we just did. Now, I know people always think that I'm just doing a check for the sake of it. If you don't do a check here, you're going to get in trouble. So we're going to make sure we use substitution into always the original equations, not any new equation that you may have manipulated. Sometimes a solution of a quadratic equation produces what we call, and that's what this one was right up here, an extraneous, should be a new word for you, an extraneous root, which means the number in a root to the equation, which means the number is a root to the equation, but is not a solution to the problem. Alright. So whenever that happens, we'll just say that it's an extraneous root. I would like you to normally write it down, and then make sure you clarify, for instance, up here, that x equals 5 was your only solution. Alright, that concludes this lesson.